Good morning, students. Today, I'll be discussing firewalls, a critical part of network security. As information systems have evolved, connecting to the internet has become a necessity for almost everyone. However, this connectivity brings persistent security concerns. Since it's almost impossible to secure every single system individually, organizations use firewalls to create a secure boundary, a perimeter defense, that helps protect their internal networks as part of a broader security strategy. Now, nearly everyone wants to be connected to the internet, whether for personal use, business, education, or other activities. With this desire for connectivity, organizations also seek to interconnect their various networks, but this brings persistent security concerns. It's important to understand that we can't easily secure every single device or system within an organization individually. Because of this, organizations typically deploy a firewall, a dedicated solution that acts as the first line of defense. A firewall helps by providing what's called perimeter defense. It acts as a protective shield between. Now, let's understand what exactly a firewall is. A firewall acts as a choke point, meaning it's a central place where control and monitoring happen between different networks. Typically, it interconnects networks that have different levels of trust, for example, a highly trusted internal network and a less trusted external network like the internet. The firewall's job is to impose restrictions on network services. It ensures that only authorized traffic, that is, traffic which meets the organization's security policies, is allowed through. Another important function of firewalls is auditing and controlling access. This means they keep logs of activities. Let's dive deeper into understanding what a firewall is. A firewall acts as a single point of defense between two networks, typically, a private network and an external network like the internet. It can be either hardware, software, or a combination of both. The main purpose of the firewall is to protect the resources of a private network from users coming in from other, possibly untrusted, networks. It enforces access control between these networks, ensuring that only legitimate traffic is allowed while suspicious or harmful traffic is blocked. The firewall has the ability to allow or deny traffic either entering or leaving the network based on predefined security rules. Using firewalls is essential because they help maintain the. Now let's talk about why we actually use firewalls. The main purpose of a firewall is to protect the network by controlling the flow of traffic between the internal network and the outside world, like the internet. First, firewalls perform packet filtering. This means they analyze packets, small units of data, as they move in and out of the network. Based on predefined rules, the firewall decides whether to allow or block these packets. In this way, it ensures that only safe and authorized communications are allowed. Second, firewalls provide a proxy service. In this role, the firewall acts as an intermediary between users inside the network and the internet. This slide gives a simple visual representation of what a firewall does. On the left, we have the internal network, also called the protected network. This is typically an organization's enterprise network where sensitive data and resources are stored. On the right, we have the external network, which usually refers to the internet, an untrusted environment filled with potential threats. Sitting between these two networks is the firewall. The firewall acts like a security barrier or gatekeeper. It monitors and controls all traffic going in and out between the internal and external networks. Its main job is to allow only authorized, safe traffic into the While firewalls are a crucial part of network security, it's important to understand that they also have their limitations. First, a firewall cannot protect against attacks that bypass it. For example, if someone physically transfers data using a USB drive, a method known as SneakerNet, or connects via utility modems, trusted organizations, or even trusted services like SSL or SSH connections, the firewall can be completely bypassed. Second, firewalls cannot protect against internal threats. If a trusted employee becomes disgruntled or colludes with an outsider, they could harm the network from inside, and the firewall would not detect or stop this. Third, Now let's take a look at the different types of firewalls. Firewalls can be categorized based on the OSI model layer at which they operate. The OSI model is a framework that defines how data moves through a network. There are three basic types of firewalls. First, the network-level firewall, which is often called a packet filter. This type of firewall filters traffic at the network layer by examining IP addresses, ports, and protocols. It decides whether to allow or block traffic based on a set of predefined rules. Second, the application-level firewall, which is also known as a proxy server. This firewall operates at the application layer, meaning it understands specific applications. Now let's focus on packet filters, one of the earliest and simplest forms of firewall technology. Packet filters are considered the simplest and fastest firewall component. They form the foundation of any firewall system and are widely used because of their speed and efficiency. A packet filter works by examining each IP packet individually, without considering the overall communication or session. This means it has no context about previous or future packets. Based on predefined rules, it either permits or denies the packet. This method is mainly used to restrict access to specific services, often controlled by port numbers. Packet filters typically follow one of two default policies. The first, let's now dive into static packet filtering, which is one of the oldest and most fundamental firewall technologies. A static packet filter doesn't have dynamic rules. It filters incoming and outgoing packets based on predefined, fixed rules set by the administrator. These rules are static, meaning they don't change in response to network traffic. They are set manually and stay the same until updated by the admin. The static packet filter focuses on a few key factors to determine whether a packet should be allowed through or blocked. These factors include the source and destination addresses of the packet, the transport layer protocol, like TCP or UDP, the source and destination ports. By evaluating these characteristics, the firewall makes. Static packet filtering was one of the first firewall technologies. It inspects network traffic based on fixed, predefined rules created by administrators. However, static filters do not understand application layer protocols like HTTP or FTP. They only look at basic network information, such as IP addresses and port numbers. The decision to allow or block a packet depends on several factors: which network interface the packet arrived on, the source address, the destination address, whether the transport layer protocol is TCP or UDP, and even the source and destination ports. These are the basic parameters that a static packet filter uses to make decisions. How does packet filtering work? Packet filtering firewalls work at the network layer, layer 3, and transport layer, layer 4, of the OSI model. When a packet arrives at the firewall, it is inspected to determine source IP address, the address from which the packet is coming; destination IP address, the address where the packet is trying to go; source port, the port on the source device from which the packet is being sent; destination port, the port on the destination device where the packet is headed, e.g. port 80 for HTTP. Protocol, the communication protocol used, e.g. TCP, UDP, ICMP. The basic packet filtering rules. Imagine you have a network and you want to set up a firewall to allow web traffic, HTTP, and deny access to a specific IP address. Objective: allow incoming HTTP traffic, port 80, and deny traffic from a specific malicious IP address, e.g. 192.168.1.100. Rules for packet filtering firewall: allow HTTP traffic, source IP address, any. Destination IP address, the public IP of your server, e.g. 203.0.113.10. Protocol, TCP. Source port, any. Destination port, 80, HTTP. Action, allow. This rule allows all incoming HTTP requests, traffic on port 80, to reach your server. Block malicious IP address, source IP address, 192.168.1.100. Destination IP. Static packet filtering refers to a simple type of packet filtering where the firewall's rules are set and fixed. These rules do not change unless manually modified by an administrator. Below are the advantages and disadvantages of static packet filtering. Advantages of static packet filtering: simplicity, easy to configure. Static packet filters are straightforward to set up and configure, making them a good choice for smaller networks or less complex environments. Less overhead, since static rules are predefined and don't require ongoing adjustments or monitoring, there is minimal system overhead. Speed, fast performance, Thank you.